Welcome to our video about the 6 trigonometric or trig functions. These are also sometimes called the circular functions because of their place on the unit circle. We already know the first two, which are sine, abbreviated SIN, and cosine, abbreviated COS. We still say sine of theta and cosine of theta, even with their abbreviations. We already know that the sine of any angle theta on the unit circle is its y-coordinate, and the cosine of any angle theta on the unit circle is its x-coordinate. The other 4 remaining trig functions that we will learn in this video are built of just the x and the y coordinates, which is why cosine and sine are referred to as the building blocks of the trig world, or all the trig functions. Our next trig function, we've already talked about a little bit, is tangent, abbreviated tan. The tangent of theta is found by taking the y-coordinate and dividing it by the x-coordinate. Another way that we can write this, so I'll just put equals under here, since the y-coordinate is the sine and the x-coordinate is the cosine, we can also find tangent as sine divided by cosine. So as you can see, the tangent is made up of sine and cosine. Now we do have an issue with tangent. What if x is 0? Well, since we cannot divide by 0 ever, if x is 0, then the tangent of that angle is undefined. Our fourth trig function is called cosecant, abbreviated CSC. The cosecant of theta is defined as 1 over y. This really means it's just the reciprocal of sine. Since sine is y and cosecant is 1 over y, they are reciprocals of one another. So if the sine of theta was 1/2, the cosecant of theta would be 2. We can also write cosecant in terms of sine and cosine, which we've already done for tangent. And this would be 1 over the sine of theta. It's just the reciprocal of sine. Our next trig function is called secant, abbreviated SEC. The secant of theta is 1 over x. So it is related to cosine in the same way that cosecant is related to sine. They are reciprocals of one another, and similarly, we can rewrite the secant of theta, since it's 1 over x, we can write it as 1 over cosine. So they are reciprocals of one another. If the cosine of theta was 1/2, then the secant of that same theta would be 2. Our last of the 6 trig functions is called cotangent, or COT for short. The cotangent of theta is the reciprocal of tangent. So it is x over y. And in a similar way, we can again define it using our building blocks, sine and cosine. And so it is written as the cosine of theta divided by the sine of theta. Now, as I mentioned previously with tangent, with these 4 trig functions, these 4 new ones in color here, they all are fractions. So they all have a potential to be undefined. If ever the denominator of any of these trig functions is 0, the trig function is undefined. So for example, for cosecant, if the y value is 0 at a certain angle, theta, then the cosecant would be undefined. Same with cotangent. If the y value was 0, our cotangent would be undefined. So this is not something we've had to deal with just yet because sine and cosine are not fractions. But for these other 4, we do have to worry when the denominator is 0, that trig function would be undefined. The unit circle literally shows us the x and y coordinate at all of these common angles on the unit circle. And so therefore it's super easy to see what the cosine and the sine are, since they're just the x and the y. However, it's a bit more work to figure out what, say, the tangent is at any one of these angles on the unit circle. So let's just pick a couple points on the unit circle and do a little exploration. Let's take a look at pi over 6, our favorite angle. Pi over 6, the cosine is root 3 over 2, and the sine is 1/2. Easy peasy. Let's find the tangent. The tangent, as we recall, is defined as y over x, or if you want to think about it, as sine over cosine. You'll get the same result either way. So let's figure out what that is. The y-coordinate is 1/2, and the x-coordinate is root 3 over 2. When we have a complex fraction here, when we have a fraction over another fraction, what we can do is either keep the top the same and then multiply by the reciprocal of the denominator, or we have an even shorter cut here. When both of the denominators are the same, you can just cancel them right away. So what we really have is 1 over root 3. Then of course we need to rationalize this so it can be written properly. So we'll have root 3 over 3. So the tangent of pi over 6 is root 3 over 3. How about the cosecant of pi over 6? Well, the cosecant we defined as 1 over y, or the reciprocal of the y-coordinate, the reciprocal of sine. Let's take a look at what our y-coordinate is here. It's 1/2. Now, before you go write 1 over 1/2, you can do this in a lot simpler of a way by understanding the word reciprocal, which just means flip it. So the reciprocal of 1/2, or our y-coordinate, is just 2. So the cosecant of pi over 6 is 2. Now let's find the secant of pi over 6. In a similar way to cosecant, the secant is simply defined as the reciprocal of the x-coordinate, or the reciprocal of cosine. So we need to take the reciprocal of root 3 over 2, which is just flipping it. So we'll have 2 over root 3, and then of course we'll need to rationalize. So our final answer will be 2 root 3 over 3. Last but not least, let's find the cotangent of pi over 6. Cotangent is defined as the reciprocal of tangent, or x over y, or cosine over sine, however you want to look at it. Let's do x over y. So we'll have root 3 over 2 divided by 1/2. We saw our trick from earlier. When we have a complex fraction and the denominators are the same, or the numerators, we can simply cancel them. So we're left with root 3 over 1, which is simply root 3. So we have found the remaining 4 trig functions for theta equals pi over 6. Let's explore another spot on the unit circle. Let's take a look at 3 pi over 2 down here. Let's start by finding the cosine and the sine of 3 pi over 2 as a brief review. The cosine would of course be 0, and the sine would be -1. Then to find the tangent, we take the sine and divide it by the cosine, so we'll have -1 over 0. Now we can't divide by 0. Therefore, the tangent of 3 pi over 2 is undefined. Next, we want to find the remaining 3 trig functions. So since we started with cosine, let's go with its reciprocal, which would be secant. The secant of 3 pi over 2 would be defined as 1 over the cosine of 3 pi over 2, or 1 over the x value. Remember, secant is just the reciprocal of the x value there. So our x value is 0. The reciprocal of 0 is 1 over 0, which we can't have. Therefore, the secant of 3 pi over 2 is also undefined, just like tangent. They're both undefined because tangent and secant both have x in their denominator of their definitions. Let's take a look at the reciprocal of sine, which would be cosecant. The cosecant at any angle is defined as the reciprocal of the y value, or the reciprocal of the sine value. So we'll have the reciprocal of -1, the y value. The reciprocal of -1 is 1 over -1, which is still just -1. So our secant of 3 pi over 2 is defined as -1. That is defined. So is the sine and cosine. So far, we've only found that the tangent and the secant at 3 pi over 2 are undefined. The last trig function that we can find is the cotangent. The cotangent is defined as x divided by y, or cosine over sine, however you want to look at it. The x-coordinate is 0, and the y-coordinate's -1. Now, 0 in the numerator is totally fine, so long as we don't have 0 in the denominator. 0 divided by any non-zero number is simply 0. So the cotangent of 3 pi over 2 is 0. Here, for each one of these 3, we want to find the exact value. In number 1, we want to find the secant of 60 degrees. So we can use our unit circle to get our building blocks, which are our x and y values. For secant, since secant is defined as the reciprocal of cosine, it's 1 over x. So we really only need the x value in order to figure out the secant at 60 degrees. Well, 60 degrees is pi over 3, and the x value is 1/2. So since the x value is 1/2, its reciprocal would be 2. So because the cosine at 60 degrees is 1/2, the secant would be its reciprocal, which is 2. Therefore, the secant at 60 degrees is 2. Next, we want to find the cosecant at 7 pi over 4. The cosecant is defined as the reciprocal of sine, or 1 over y. So all we need to know is the y value at 7 pi over 4. So let's take a look at 7 pi over 4. It's down here in quadrant 4. And we can see that the y value at 7 pi over 4 is negative root 2 over 2. So we need to take the reciprocal of negative root 2 over 2. So it'll be negative 2 over root 2. I'm just taking the reciprocal. Then we need to rationalize the denominator, and we'll get negative 2 root 2 over 2. Our 2's will end up canceling, and then our final answer will be negative root 2. In problem number 3, we want to find the cotangent of 3 pi. The cotangent is defined as the x-coordinate divided by the y-coordinate, or the cosine divided by the sine. Now, where is 3 pi? We know that if we go around our unit circle one time, that's 2 pi, then we need to go around an extra 1 pi to get to a total of 3 pi. So 3 pi is the same as just 1 pi. It's over here at 180 degrees. Our x-coordinate is negative 1 and our y-coordinate is 0. So cotangent, again, is defined as x over y, and our x-coordinate over here is negative 1 and our y-coordinate is 0. Anytime we divide by 0, we are not defined. So the cotangent at 3 pi is undefined. Here is a table partially from the other video. So these first 4 columns are from the previous video with sine and cosine, and this is giving just the main points on our circle and for the different families, the common cosine and sine values that we see. Then I added on the tangent and cotangent. So what I'd recommend you doing is going back to that part in your notes and extending on to this table. If you didn't already write it down, it would be helpful to write down this whole table here. We can see that the pi over 6 family, the pi over 4 family, and the pi over 3 family are all included. And their tangent and cotangent values are root 3 over 3, 1, and root 3. And obviously they're swapped here for these two. So again, there's lots of patterns on the unit circle. Then we can clearly see that tangent and cotangent at times are undefined. So we do have to be sure that we understand when something is 0 versus when it's undefined. So if you have not gotten this down already, make sure that you pause the video and get this table copied down in your notes. For these 3 problems here, we want to find all the values of theta that give us the certain output for the particular trig function. So in number 1, we want to find all the potential angle measures for theta such that the secant of that theta is 2. Well, in this case, secant, as we have learned in this video, secant is the reciprocal of cosine. So what this really means is we want to know where is the cosine of theta equal to the reciprocal of 2, which is 1/2. So these two things are equivalent. So basically, we're looking on our unit circle and we want to see where is the cosine of theta equal to 1/2. What angle measures give us an x value of 1/2? We can definitely take a look at our handy dandy unit circle. The cosine, as we know, is the x value, so it is positive in these right 2 quadrants, quadrants 1 and 4. And the cosine is 1/2 in our pi over 3 family. So the cosine is 1/2 at pi over 3. The cosine is also 1/2 at 5 pi over 3. That means that the secant is 2 at pi over 3 and 5 pi over 3. So our 2 angle measures that give us a secant value of 2, aka a cosine value of 1/2, were pi over 3 and also at 5 pi over 3. Now, in order to get all of the potential values of theta, we could obviously keep going around the circle. Every time around is 2 pi, so we can add on 2 pi k and 2 pi k here. And showing, so I'll just write and here, we can say that k is an integer. K is an element of the set of integers. You can also just write k is an integer. In problem number 2, we again want to find all the theta values, but in this case, we want to know where is the tangent of theta equal to root 3. Now in this case, it's difficult to look at the unit circle and see where the tangent is root 3, because on our unit circle, we can just see x and y, or cosine and sine, and it's not an easy one to take a reciprocal of like secant was and get cosine. So let's use the chart that we just took a look at. We can see that the tangent is the square root of 3 at the pi over 3 family. Now, where is tangent positive root 3? The tangent is positive in quadrants 1 and 3. If you recall that all students take calculus, in quadrant 1, all of the trig functions, all 6 actually, are positive. And then in quadrant 3, for take, that means tangent is positive. If we now take a look at our actual unit circle, let's make sure that at the pi over 3 and at the 4 pi over 3, so quadrants 1 and 3, let's make sure our tangent is in fact positive root 3. If we take a look at pi over 3 right here, we know that tangent is y over x or sine over cosine. So the tangent here would be root 3 over 2, the y value, divided by the x value, 1/2. We can cancel the 2's and we are left with root 3 over 1, or just root 3. So the tangent is root 3 at pi over 3. Let's check now down at 4 pi over 3 and make sure this one works as well. We can clearly see that we have the same x and y values as we did up here, except now they're both negative. If we took the y over x to find the tangent at 4 pi over 3, we would still have positive root 3, since a negative divided by a negative would be a positive, so we'd have the same thing here. So the tangent is positive root 3 also at 4 pi over 3. Now we have an interesting thing going on here in that our two angle solutions, pi over 3 and 4 pi over 3, are exactly half of the unit circle apart. So we can answer this as one answer. We can start with our answer at theta equals pi over 3 and just add a half a circle, or 1 pi. If we keep adding a pi, we'll keep ending up to where we want to be. So in order to include both of those answers, we'll say that we want theta to be pi over 3 plus pi k, where k is an integer. Again, this is saying k is an element of the set of integers. You could also write out k is an integer. This is getting all of the solutions that we want, both pi over 3 and 4 pi over 3, since they are like a symmetric amount apart on the unit circle. In number 3, we're looking for all the values of theta such that the cotangent of that theta is -1. Well, the tangent and the cotangent are both 1 in our pi over 4 family. That means that they would be -1 in the quadrants where they would be negative. So where would cotangent be negative? Well, since cotangent is x divided by y, or cosine over sine, in order for that cotangent to end up being -1 like we want, the cosine and the sine, or x and y, need to be opposite signs. Like one needs to be positive and one needs to be negative, so that when we divide them, we'll get -1. Where would the cosine and the sine, or the x and y, be opposite values? Well, that would be in quadrants 2 and 4. If we take a look at our unit circle in quadrant 2 and then again in quadrant 4 at our pi over 4 family, we will be at 3 pi over 4 and 7 pi over 4. The cotangent here would be -1. Let's see why. The cotangent is x divided by y. I'm not even going to write this out here, I'm just going to talk about it. If we took this value, -root 2 over 2, and divide it by its positive value, root 2 over 2, we're dividing something by itself, but one of them is just negative. Our output would be -1. So the cotangent of 3 pi over 4 is -1. Same reasoning with 7 pi over 4. These are the two spots on our unit circle where the cotangent is -1. We can start with our answer being 3 pi over 4, and then again we'll have to add 1 pi to get to our next answer. If we keep going around the unit circle, we keep adding 1 pi to get halfway around the unit circle every time. Therefore, our answer here is theta equals 3 pi over 4 plus halfway around the unit circle, k amount of time, so plus k pi, and in this case I'll write it out in words. We want k to be an integer. So we have used the chart that was provided as well as the unit circle to answer all of these problems here, finding all the values of theta so that we get the output that we want for our trig function. We have talked a lot about these 6 trig functions, so here is one final way to sort of show them all off. This is the last way that we can write out these 6 trig functions. We already know that the sine, cosine, and tangent can be found using the right triangles using SOHCAHTOA, where the sine of an angle is the opposite side divided by the hypotenuse, The cosine of theta is the ratio of the adjacent side divided by the hypotenuse, and the tangent of theta is the ratio of the opposite divided by the adjacent sides of this right triangle formed. The cosecant, secant, and cotangent are the reciprocals of these three original trig functions. So therefore, we can find the cosecant of that angle by taking the reciprocal of the sine. So the cosecant of theta is the hypotenuse divided by the adjacent, and so on. This is the final way to sort of represent these six trig functions, and we can also use this way to solve problems. Let's answer some more problems about these trig functions, these ones being a little bit more specific. In these problems, we're given one of our six trig functions is about a specific angle theta, as well as the quadrant that theta is in, or its terminal side is in. We then want to find the remaining trig function, so we want to find the other 5. So let's write them all out so we can sort of see what we need to find. I've written out the 6 trig functions as well as the one that we know. Then this information here, the fact that theta is in between 0 and pi over 2, that means that we're in quadrant 1. In quadrant 1, everything is positive. In the other video, we learned about all students take calculus. Quadrant 1 is where all, meaning all 3 of these original trig functions, are positive. That means their reciprocals are positive as well. So the first one that we know is the reciprocal of cotangent, which is tangent. The reciprocal of 2 is 1 over 2, or 1/2. In order to find the remaining 4, however, we do need to sketch out our angle. So here is our right triangle with our angle theta and our right angle over here. We know that the tangent is 1 over 2. Tangent is opposite over adjacent. So we can write that the opposite side is 1 and the adjacent side is 2, given that information. We also could have used the fact that cotangent is 2, or 2 over 1, and cotangent is adjacent over opposite, 2 over 1. So this gives us the same information. Then we need to use the Pythagorean theorem to find the hypotenuse. We find that our hypotenuse is the square root of 5. Now we can begin finding our sine and cosine. Sine is katoa, so sine is opposite divided by hypotenuse, 1 over the square root of 5. When we multiply the numerator and denominator by root 5, we'll get 1 root 5 over 5. Then we can find this reciprocal of either or in order to get the cosecant. I'm going to take the reciprocal of 1 over root 5, that way I won't have to rationalize again. The reciprocal of 1 over root 5 would be just plain old root 5 over 1, or root 5. So our cosecant is the square root of 5. We also know that the cosecant is hypotenuse divided by opposite, which is just the square root of 5. Next, we can find the cosine of theta. Cosine is adjacent divided by hypotenuse, so 2 over root 5. When we rationalize and multiply the numerator and denominator by root 5, we'll get 2 root 5 over 5. Now, in order to find the secant is the reciprocal of cosine. To take the reciprocal of this, we'll just flip it, so we'll get root 5 over 2. Another way to think about this is that the secant is the hypotenuse divided by the adjacent, root 5 over 2. We have successfully found our 6 trig functions, well, 5 of them. In problem number 2, we're given the information that the secant of our angle theta is 2 root 5. We can also think of this as 2 root 5 over 1, since we like thinking about these as fractions. This information over here tells us that theta is in between 3 pi over 2 and 2 pi. That is giving us the information that we are in quadrant 4. I'm going to write the secant as 2 root 5 over 1. We know that the secant is the reciprocal of cosine. So since cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. That means that our triangle looks like this. The hypotenuse is 2 root 5 and the adjacent is 1. Now I drew this triangle to look like it's in the 4th quadrant, going down. So this is like our x-axis and this is going down. So this means that we actually know what the cosine is. The cosine of our angle is adjacent divided by hypotenuse. So we have 1 over 2 root 5. In order to simplify that, we can rationalize it by multiplying the numerator and denominator by root 5. When we do that, we'll have root 5 over 2 times 5, which is 10. So our cosine is root 5 over 10. Now we need to find the missing side length using the Pythagorean theorem in order to find the remaining 4 trig functions. So solving the Pythagorean theorem, we'll have 1 plus y squared. And then when we square 2 root 5, we'll have 2 squared, which is 4, times root 5 squared, which is 5. So we'll get 20. When we subtract 1 from both sides, we'll get that y squared equals 19. So taking the square root, we'll have that y is the square root of 19. Now, if you want to think about this value as negative, that's completely fine. Because we're in quadrant 4, in order to get down here, we had to move to the right, so our x value is positive, but then down, so our y value is negative. So we can label this as negative root 19. That'll help us because then that tells us that our sine and tangent are actually both negative. Let's see why. The sine of theta is defined as the opposite divided by the hypotenuse. Therefore, our sine is negative root 19 over the hypotenuse 2 root 5. When we rationalize this by multiplying both numerator and denominator by root 5, we can multiply under the roots, so we'll get negative square root of 95, which actually can't be broken down, and divide it by 2 times 5. Root 5 times root 5 is 5, so we'll have over 10. Now, in order to find the cosecant, we have to take the reciprocal of sine. We can either take the reciprocal of the original sign or take the reciprocal of this. Either way, we're going to have a square root in our denominator, so I'm actually going to take the reciprocal of the original because I think it'll be less simplification in the end. So we'll end up having negative 2 root 5 over the square root of 19. The negative I actually just brought into the numerator since only one part of our fraction is negative, so that means we only need to write it in the numerator. Then, in order to simplify here, we'll multiply both the numerator and the denominator by the square root of 19, which in our numerator will give us negative 2 times the square root of 95 over 19. And that cannot be simplified since 2 and 19 can't be simplified and we cannot break down the square root of 95. All right, this one's a little bit crazy. Let's take a look at the tangent of theta next. And these will just be our last two. So the tangent is defined as the opposite divided by the adjacent. So that one's not too bad. It'll be negative root 19 over 1, which is just negative root 19. Then cotangent is defined as the reciprocal of this, or adjacent divided by opposite. So we'll have 1 over negative root 19, so the negative can just go out in front. Then we'll rationalize, and we'll get negative root 19 over 19. So we have found, given only the secant and the quadrant that we're in, the 5 remaining trig functions of theta. Remember, what these trig functions are doing is they're giving us the ratio of the side lengths formed from the right triangle from this specific angle, theta. In this video, we have gone through these 6 trig functions or circular functions. We have defined them using x and y and talked about their place on the unit circle. We've also defined them using sine and cosine, which are the y and x, or the building blocks of trig. Lastly, we've defined them using the side lengths of the right triangle, opposite, adjacent, and hypotenuse. We've used these 6 trig functions to solve problems in trigonometry.